Hey everyone, Dr. Green here again. This is our final simulation example. This is a very complex inventory example. We're going to work through this pretty slowly. We're going to do our best and see exactly what we come up with. So Quick Storage is a company that prides itself on always having enough of its products in stock. They've asked you, a simulation analyst, to develop the most efficient reordering strategy for the company, the best strategy to minimize cost. They currently have 25 units of product in stock. The company also has a policy on reordering. If less than 30 units are available, you must reorder a lot of 40 units. Each order costs a total of $150. Any lot ordered may arrive in 2, 3, or 4 weeks with a given probability. Quick Storage also sells units of product to distributors whose demand varies from month to month. A study of past information has revealed that distributors order between 14 and 18 units in any given month with likelihoods of 20%, 40%, etc. If you're unable to meet the distributor's demand, a cost of $100 is incurred for every unit of lost demand. What is the most efficient reordering strategy? That the reorder point can be varied between 15 and 50 units, and that the lot size can be adjusted to contain between 20 and 80 units. How confident are you in this answer? So this was a lot of information. What we are going to look at is a rather complex model that mixes many probabilities, random values, and lots of things. So we're going to do a long simulation here. We are going to start off just modeling 4 or 5 weeks, maybe 6 weeks to get started. I have put all this information in here. First, we have reorder point and lot size. So at 30, we order lot sizes of 40. Cost per order is $150. The holding cost is 1. If you're out of stock, you pay a $100 fee. Right? You'll remember this. We have this $100 fee buried in here. If Quick Storage is unable to meet the distributor's demand, a cost of $100 is incurred for every lost unit of demand. That is our stock out cost. We have probabilities for demand and lead time. Now, one thing I've already filled in here is this idea of cumulative probability. When I look at cumulative probabilities, I'm going to build up a likelihood going up from 0 to 1. So I start with 0. Then you'll see here I add my probability to 0. That means that for a demand of 14%, any random value I generate between 0 and 0.2 means 14%. From 0.2 to 0.6, I have a probability of 0.4. You'll see we just add this up and drag it down. The same with 0.8, and anything above 0.9 gives me this 10% chance of having a demand of 18. The same is true with probability and lead time. And now as we walk through this model, you will see how this all plays out. We will start in week 1. Our starting inventory is that 25, if you remember correctly. We had an initial starting inventory of 25 over here. We do have an order of quantity received. How much of our order did we actually get in? Well, you'll see it takes at least 2 weeks for us to get any order, so we're going to go ahead and assume that for the first 2 weeks, we are unable to receive anything. Why? Because if I had ordered it, I'd have to wait 2 weeks. I have no control over the weeks before this, so the earliest we can place an order is week 1, which means the earliest we can receive an order is week 3. So I have a starting inventory, a quantity received. My adjusted inventory is my starting inventory plus my order quantity received. Okay? I then have a demand value. Okay, I have a demand. For this, we are going to use a new function. We are going to use a VLOOKUP function. I'm going to type out this whole thing first. It's VLOOKUP rand. Okay? We are going to look into our demand here. We're going to lock that. And we're going to say 2. Now, why did I do this? What this does is it generates a random value, and it does a vertical lookup. So it generates a random value, something between 0 and 1. It looks up where that value falls in this first column on the left. Once it decides where it should go, it looks at the second column and takes the value. Okay? So you'll see when I press enter there, it picked 16. That means we had a value between 0.6 and 0.8. If my value was 0.95, I would have gotten 18. If it was 0.15, I would have gotten 14. Okay? So this is a way that we simulate this demand. I will press F9 here. I'm going to be a little tentative around doing this because I have a lot going on in this spreadsheet and across my entire workbook. So you'll see that does jump around a bit. Now that we have received inventory, we have an adjusted inventory, we have demand, all this, you'll see it keeps jumping because it's running other simulations. My ending inventory is my adjusted inventory minus my demand. Okay, so I end up with about 10. Next, I want to know if I should place an order. Well, when do I place order? If I'm below my reorder point. Here, we are going to use an if statement. If my ending inventory is less than my reorder point, yes. Otherwise, no. Now, you could use 0 or 1s here. Yes and no works really well because you know that people are going to want to read this. They're going to want to see your model, all that kind of stuff. We want to know how long the lead time is going to take. So again, we're going to do our VLOOKUP function. Rand. This time, we're going to look at our lead time table. And again, we are going to take column 2. Now, this works just the same way as demand. It generates a random value between 0 and 1, sees where that falls on that scale. So if it's between 0 and 0.6, I'll get 2. Between 0.6 and 0.9, I'll get 3. And above 0.9, I will get 4. Hit enter, so I have a lead time. My order cost is going to vary, right? So I say, if I am ordering, right? If I am ordering anything, okay, it is simply the cost of an order, right? So my lead time is this. Am I placing an order? Yes. Oop, not my lot size, my lot cost. In any other case, it's just 0. Right? So if I order some, it's 150. You'll see that that is there. We can make that look like dollars and cents. My holding cost in this case, right, is a per unit cost based on my ending inventory. So it is my ending inventory times my holding cost per unit. That holding cost is never going to change, so I'm going to lock it. Okay. My stock out cost, right? My stock out cost is going to be a little different here because stock out cost is all about if I am out of anything. So this is going to equal if, right? So in any case here, we're gonna have to check some things. So basically, if my demand is greater than my inventory, if my ending inventory is 0, well, then I have to figure out what this value is going to be. Well, it's going to be my stock out cost multiplied by, right, my demand minus my inventory. In any other case, it's just 0. So you see in this case, it is 0. And then my total cost is just the sum of my stock out cost, my holding cost, and my order cost. So you'll see here in this week, I have $160. Okay? One thing we are going to do to make this a little bit more computationally efficient, the lead time, we're going to say if this equals yes, then do the VLOOKUP. In any other case, nothing, right? So we can actually change this to 0 or an empty cell. It doesn't matter, okay? Because we just have no lead time. What that lets the Excel spreadsheet do is it can sort of short circuit and it doesn't have to generate an extra random number. That may not seem like much, but it's a big deal, okay? So we have finished one period. We have gone from a starting inventory to what we've received to my adjusted inventory, demand, ending inventory, placing those orders, and everything else. Okay, so here I have my starting inventory. My starting inventory is just going to be my ending inventory, right? So that's 10. I've received nothing. My adjusted inventory is going to be the same. Well, and my demand is going to go down here. I'll see what my demand is, and then my ending inventory is, oh, -5. That is not a good thing. We do not want to have negative inventory, so we have to do something about my ending inventory. So let's do this. If this is less than 0, then it's going to be 0. In any other case, just use the value. Okay, so I have 0. That makes sense. I'm going to look here. If that's less than the reorder point, order yes. My lead time calculations are going to be exactly the same. My order cost, exactly the same if I'm ordering. My holding cost, exactly the same. You'll see that's 0. Now my stock out cost I should be charged something here. So we lost $100 per unit, right? Because our demand was above our inventory. And we can make all this look like dollars and cents. And then my total cost is, again, just drag it down and we'll see that. Okay? So we can go week by week doing this. Now you will see the one place that I have not entered anything is right here. The rest of these cells are basically the same. Okay? They are going to go down. They're going to do anything that we want. But what we really have to look at here is when do we get orders and how much of that order do we get? So we know that we have these lead times. They may be 1 or 2 weeks, 3 weeks, or 4 weeks. So we'll look at it this way. When do I receive an order in week 3? Well, the only way I receive an order in week 3 is if the lead time here is 2. Then, if it is, I get my lot size. In any other case, it's 0. That's the only way that I can get anything here. Okay, so that's really, really quite clean. But you'll see I will get something there. If I look another week ahead, well, it is that, but it's also this other thing. If the lead time here was 3, then I also get my lot size, or 0. Okay? So what this says is look 2 weeks back, and if my lead time was 2 weeks, add the order. Look 3 weeks back, and if my lead time was 3 weeks, add the order. And now we can go one step further, and we can say plus if 4 weeks back, the lead time equals 4, then value if true, lot size, lock that, otherwise 0. So you'll see we're adding up the orders from every single week here. And now this will continue on indefinitely. And you'll see it goes to 4 weeks ago, 3 weeks ago, and 2 weeks ago. The rest of my formulas are easily dragged and dropped down here. Okay, so you'll see we can do this whole thing. And if I press F9 real quick, we'll do one F9. You'll see, are we placing orders? No, my demand, my lead time, everything is shifting. Right? So you'll see this. The reason we're getting multiple jumps here when I press F9 is because this Excel workbook is simulating things on other sheets, so it's doing lots of other calculations. So you'll see we run out of inventory, and then we get inventory in, and then we don't get any inventory, and then we sell some, and we're going to be doing this. Now, what we want to do is we want to decide, we had this question at the end of this problem. We decide down, what is the most efficient reordering strategy, assuming that the reorder point can be varied between 15 and 50, right? And the lot size can be adjusted to contain between 20 and 80 units. So what we want to do is we want to build a good simulation here. So the first thing I am going to do, I'm going to go here. I am going to go up to my edit, fill based on a series, fill on my column. I want linear. Step value, my stop value, I'm going to make this pretty long. I'm going to go for 300. I'm going to select this whole row now because I know my formulas are correct. And I'm going to fill all the way down. And again, I'm going to go to row 4, hold down my shift key, tap and release in, tap and release down. It'll bring me there. Go back up a couple and hide these rows. Okay, so you'll see I got a lot here. So we can look at our average weekly cost, because we want to see what we're doing here. So we'll say, what's my average weekly cost? Total cost for the week, right? 5807 right now is our average weekly cost over 300 weeks. That's not terrible. Like, we're in pretty good shape here. We're having a good old time. We're working through this, doing all this kind of thing. Now we have to decide about these reorder points. So we have 2 things in our arsenal, right? One is a one-way table, the other is a two-way table. Really, we want to jump straight to the two-way table here. So the first thing we have is our reorder point. 15, 20, 25, 30, 35, 40, 45, 50. Okay, we're going to make this look nice. We're going to merge and center this. We're going to call this my reorder point. We'll even go in here. We'll go to Format Cells. We'll change the alignment so it looks nice and slick. Okay, we're going to do that. And then over here, we also have lot sizes, 20, 30, 40, 50, 60, 70, and 80. Okay, we'll do the same thing here, lot sizes. Now the value I'm looking at is this average weekly value. So if you remember with two-way tables, I'm going to put this right here. Give it a good old reference. Okay. Right, so we are generally in pretty good shape here. We are looking through all this kind of stuff. And the next thing we want to do is build a data table. So if I do this, I go to data, go to my data tab, my what if analysis, data table. You remember my row input cell, that's whatever I want to move across here. That's my lot size, so I'm going to select that. My column input cell, I'm no longer doing iterations, I'm doing a reorder point, so I want to select that column input cell. So it's going to take all these values, plug them in here, get this. These values, plug them in lot size, and do the simulation. In here, it's going to enter all of the average weekly values that I'm looking at every time it runs that simulation. So if I press OK, you'll see they all look the same until I press F9 and make my spreadsheet recalculate. Now this is going to take a second here because we're now doing lots and lots of random calculations and what ifs and simulations and the like. But in one moment, we should end up with a nice data table. You'll see I have values here now. It's working through those final calculations. And we are good. Okay, so here's the thing. I can barely tell what's going on here. Great. Okay. Still can barely tell what's a good value, what's a bad value. One of the things I can do is go in a conditional formatting. I can do some color scales. Green, is high. Well, it wouldn't make red the highest because, low is good. So let's go green. You will see here, well, that's expensive, this combination of 15 and 20. The brighter green, I want to start looking down in areas down here to minimize my costs. So it gives me a nice visual way to look at my data table and see what I'm doing. The other thing we do need to do is look at how confident we are in our how confident that we are in our answer. So we want to do this within a confidence interval. This is going to be my standard deviation P. Pick that formula, do the same thing here. Okay, that's a very high standard deviation. You'll see that right there. We will do my lower 95% CI, upper 95% CI. And if you remember here, this in both cases, the lower equals my average minus 1.96 times the standard deviation divided by the square root of the total number of samples, 300. We can go through and actually lock all these because they're never going to change. We just need to change the sign. And then we'll go in here, make that a plus. All right, so this is quite the range, 95%. We probably want to build a little bit better model in this case. But overall, this is a very complex model. This is a multi-period simulation model using if statements and random variables and cumulative probabilities and VLOOKUPs to do all the appropriate calculations to arrive at a robust simulation model that you can use to convince your bosses of the best plan possible. It is data-driven, it is based on data analysis, and it is thorough. And based on what you've seen here, you should all be good to go.